Okay. Now this mensuration. I am Fusili Abdurazak, popularly known as Ninja Man. Let's have a question on a circle. Area of a sector that relates to a cone. The relationship between a sector and a cone in mensuration. That is the work today. Now, a sector of area 427 centimeters square is cut out from a thin circular metal sheet of radius 17 centimeters. It is then folded with the straight edges coinciding to form a cone. Calculate the correct significant figures. The angle of the sector, the length of the arc of the sector, the height of the right circular cone, the volume of the cone, the curved surface area of the cone. That's right. Let's have a look at it. All that this person is talking about is that if you have a sector, what is meant by a sector? A sector is created when you have radii and two radii cut off by an arc. Then it becomes a sector. So if you have this radius, see that cut off by this arc. So if here's A, B, O, A, B is a sector. So the whole of this is a sector. And up there is also a sector. It's a sector. Because this is an arc. And closed by this two radii, AB and AO and OB. So what the question is saying is that let's pick this top one. This top one. This one has an angle. It's the angle here alpha, angle here theta. The relation between the angle alpha and theta is that theta plus alpha should be equal to 360 degrees because a circle has a total angle of 360 degrees. Now, this angle has not been given to us. This angle has not been given to us. This angle has not been given to us. But what has been given to us is the area, the shaded portion. The area shaded with red marker has been given as 427 centimeters square because it's an area. But the angle here, let's say alpha is not given. The angle alpha here is not given. And we are told that the area at the top there is cut off from the circle. So let's say it is cut off. So this part is no longer there. It's cut off. Just like this. This is the whole circle. This is the whole circle. This one becomes the whole circle. And the top one, the area of the top one, is cut off. And it's taken. This part is taken. And this part that has been taken. With the angle here. The angle here. We are looking for this angle here. The radius here has been given. The radius has been given as 17 centimeters. The radius 17 centimeters. 17 centimeters. And in fact, the whole area has been given. The area of the sector has been given. And the formula for area of a sector is theta over 360 times area of a sector. Area is equal to theta over 360 times pi r squared. The theta is the angle here, which is now alpha. So area, which is 427, because the area has been given to us already, so we substitute 427 into the formula. So which is 427 is equal to, I've changed my angle here to be alpha. So alpha over 360 degrees times pi. Pi is not given. So we pick 22 over 7 times the radius. The radius is 17 centimeters given in the question. So the radius is 17 squared. So press 17 squared times 22 times alpha.
70 squared times.
So 427 is equal to 17 squared times 22. What do you get?
6,358.
So times alpha will give it, because this one will give it 6,358. Not so?
Yes.
6,358 times alpha will give it alpha. 6,358 alpha. You square this, multiply by this, because you multiply the numerators divided by the multiplication of the denominators. Divided by 360 times 7.
2,520.
2,520. Now, what we do is to do cross multiplication. 6,358 alpha times 1 will give us 6,358 alpha, which is equal to 2,520 times 427 will give us 107 110 like this.
No, 1076.
Okay.
76
76
0
0
40.
40. Now, if you want alpha, what do? You divide this out by 6,358. 6,358. So this one cancel this, and alpha is equal to
169.
169.2419.
249.
Not so?
19.
2419. So alpha is approximately equal to 169. Not so?
Yes,
Degrees to 3 significant figures. So alpha gives us, so our angle, which gave an area 427 centimeters square, is 169 degrees. 169 degrees. That's the area. That's the angle. That's I. The first question says we should calculate the angle of the sector, and that's the angle which gave 427 centimeters square. Now, the second one is length of the arc of the sector. Length of the arc of the sector. Length of the arc of the sector. Good. Now, since we know the area of the sector, length of the arc, let's calculate. But we have different ways of calculating for the length of the sector. But now let's use what we do. After that, I will reduce it to a very simple formula for you. Length of the arc, L, should be equal to theta over 360 times 2 pi r. What is our theta? Our theta is now 169 degrees. So L is equal to 169 degrees divided by 360 degrees times 2 times pi, 22 over 7 times the radius 17. Divide, okay, multiply 169 times 2 times 22 times 17. 2 times 22 times 17 times 169, you multiply all together. What do you get?
126.
L is equal to 1, 2, 6,
4, 1, 2.
4, 1, 2.
Finish.
That's all.
Yes.
Divided by 368 times 7. I think that one will give 2520. No, so 368 times 7 give 2520. That is it. 2520.
That's correct.
Now, L will be equal to 126,412 divided by 2520. What do you get?
50.163
50.1635. So length of the arc should be equal to 50.1635. 2 centimeters. This should be centimeters because the length of the arc. So we have calculated for the length of the arc. We are done with the length of the arc. So one simple thing is that, you see, look at this. Area of the arc formula, area is equal to theta over 360. So theta over 360 times theta over 360 times pi r square can be written as theta times pi r square will give us pi r square theta over 360. So this will give us pi r square theta over 360. Let this one be equation 1. Then equation 2, length of the arc, theta times 2 pi r will give us 2 pi r theta over 360 degrees. Equation 2. You see that? This is how we reduce formulas for especially those who do science and math quiz. So that when they are calculating, they don't go by this. It becomes very simple. So now, divide equation 1 by equation 2. So it will be A over L should be equal to equation 2 pi r squared theta over 360. Since I am dividing, this one will go up because it will be divided by 2 pi over 360. But when we are taking multiplication, this one will go up. So times 360 over 2 pi r theta. This one cancel this. Theta cancel theta. Pi cancels pi. R will cancel one of the arrows here. Not so. So that should be A over L is equal to, what is at the top here? R over 2. Not so. So if I calculate the length, this one will multiply 2A is equal to L R. Not so. So if I want L, I will divide by R. This cancels this. So that we have the length of the arc should be 2 times the area over R. So instead of me using this long formula to go by this, using this long formula, what I'm proving here, L is equal to 2A over R. Now look at it too. L will be equal to, you have gone by this simple. 2 times the area of the arc, which is what? 427. Over the radius, which is what? 17. Press 2 times 427 divided by 17 and see whether you get this. Obviously, you have to get
50.2
2
35.
35. So which is 50.2 centimeters. You see how it is? You see how simple it is? So if you are to the students who are going for science and math quiz, you would have reduced all this formula for this. So that as soon as you give them the area, then the radius, you see that they will calculate and you will be marveled. That how were they able to come out with that answer? But always a mathematics teacher has to look for relationship between mathematical expressions and try to reduce them. So this one, through that, I can find a way of making theta very easy. So that if you want to find the angle, you won't even go by this method. That's also there. Now, let's continue. That's there by the way. Let's continue with the solution. Now, the next is that the height of the right circular cone. The question says that the length of the area of that circle that was cut was folded with the straight edges here, the radius, coming together to form, coinciding to form a cone, coming together to form a cone. You see, look at this. This one is radius of the circle, also. Let me make a capital R, radius of the circle. What is 17? Look at it carefully. Look at it carefully and get the understanding. So I'm folding the remaining. I'm folding it. the area of sector, which is 427 centimeters square, is cut out from a thin circular metal. Whatever it is a circle because of the word circular. So it is cut out from the circle, and I'm folding it to form a cone. You see the radius. Have you seen the radius of the circle? This is the radius of the circle. When I fold to form the cone, you see, the radius becomes the slant height of the cone. The side, you see that? Look at it. When I fold, slant height. So you see that when I draw the cone, you will see that this is the height of the cone itself, h. This is the radius. But the slant height, have you seen this side, is r, which is equal to the same L, which has become the radius of the circle has become the slant side or the slant height of the cone. When you fold it to form, you see that when you use it to form, you see that. That's how it is. Now, so this R, the radius of the cone, which is equal to 17 centimeters. So here is 17 centimeters. Clearly, it has been shown. This is the height of the cone, and this is the radius of the cone. Now, let's look at something. Let's look at something fantastic also here. If you fold it, you will see that the radius becomes the slant height of the cone. But look at what happens to the length of the arc. This is the length of the arc. Not so. When I fold it, the length of the arc becomes the circumference of the base of the cone. The circumference of the base of the cone. You should look at it. Have you seen it? This is the length of this arc. Not so. What is 50.2? Let me fold it. You see? Let me fold it. If you fold it, you see that it has become the base. That arc, which we calculate the length of the arc, you see that it has become the length of the arc. When I fold it again, it becomes the circumference of the base. I want you to understand. And this is a cone. You see, like the funnel. So, the length of the arc, which is theta over 360 degrees times 2 pi r, I'll make this 2 pi r, this capital R, becomes the circumference of the base of the cone. Not so. And the circumference of the base of the cone, circumference is 2 pi what? R. But in this case, the R here is small r. Do you see that? Because the base radius of the cone is now different from the area, the radius of the original circle. You see, this circle, the base is different because this circle is only formed by the circumference of the arc alone, not the whole circle. This arc which was cut out of the circle, this part. So this part only forming a circle. Definitely, nobody should tell you that radius will even be smaller than this radius. It is obvious, and by common knowledge, and by simple logical reasoning, because it is part of this, just part of it, forming the circle. You see, it's very circular, and that radius will be different from this radius. This radius is now forming this side. So now the whole of this has been calculated. This whole thing has been calculated as 50.2, which is equal to 2 times pi. Pi is 22 over 7 times r. Not so. R is not known. So we shall have 50.2 is equal to, if you multiply this by, this will give 44, not so, over 7 what? Is that not true?
Yes.
So if I multiply everywhere by 7, this one will be 50.2 times 7 is equal to 44 R. Not so? And I will divide both sides by what? 44. So this one will take off this. So R will be equal to 50.2 times 7 divided by 44 gives
7.986.
7.986.
86.
So I will leave it to be 7 point, okay, I will leave the radius to be 8 centimeters. Okay, 7.986. I'll put it like that, the radius. So here is 7.986. Continue with the third question. Having calculated a small radius, R to be equal to 7.99. Now, if pick the cone, now the base radius of the cone is 7.99 with the slant height L is equal to the original radius of the sector, which is 17 centimeters, and this is the height of the cone H. Now we have three variables involved. Then L, small r, and H. So if you know 2, you can calculate for the third one. So from this, we apply Pythagoras theorem to triangle OAB. So we shall have 17 squared is equal to 8 squared plus 7.99 squared. So that this one is positive, will be negative here. 17 squared minus 7.99 squared, which is equal to 8 squared. Then you have 8 squared to be equal to 225.16.
16, yeah.
225.16. So you take square root 8 is equal to square root of 225.16. You get H to be equal to 15.00, and also.
Yes.
So in that case, we 15.0. So the height of the cone is 15.0, as the question was demanding us to do. In the third question, the height of the right circular cone. So the height of the right circular cone is 15.0. Now, we have to calculate the volume of the cone. The volume of the cone, V, is equal to 1/3 the volume of a cylinder, which is R squared H. So V is equal to 1/3. The pi is 22/7. And the radius, which is 7.99, should be squared times the height. The height is what we have calculated for 15. Now, we have V to be equal to 22 times 7.99 squared times 15, all divided by 3 times 7, 21. So V will be equal to, compute this on your calculator and let's see what goes. Press 22 times 7.99 squared times 50. What do you get?
1003. 3.201.
201. Then divide the answer by 21.
That's the final answer.
That's the final. You divided all by 21.
Yeah.
So V is equal to 100 centimeters cubed.
103.
103. Yes, thank you. Is that 3 single figures?
Yeah.
So 103 centimeters cubed. And the funnel is the curved surface area. The curved surface area of a cone is S is equal to pi r L. This is the formula for curved surface area. And in the previous video, I have taken my time to explain most of these concepts. So you better look for some of the videos on circles, most of the videos on circles. But this, I also explain why it is pi r L. You realize that when you pick a cone, this is the curved surface area. This is the curved surface area of a cone. Curved surface area. And that curved surface area is the area that formed the sector is equal to this area. And the area of a sector is given by theta over 360 times pi r squared. Because this arrow should be different from the arrow in the cone, because it is part of the sector that forms the base of the cone. And that part of the sector that forms the base of the cone is the length of that arc of the sector forms the circumference of the cone. So that is 2 theta over 360 times 2 pi r, which is the length of the sector, is the one that forms the circumference of the cone, which is 2 pi r. So if you divide 2 by 2 pi, this cancels that, and you get this 2 pi cancels this 2 pi, you get small r equals theta over 360 times capital R. So this one has a relationship with this. What the relationship very well? You will see that this one, you're talking about the total surface area. The surface area will be equal to this one can be written as theta over 360 degrees times R into bracket pi R. So that when this one multiply this one, you will get theta over 360 times pi R squared. You see? And theta over 360 times R is small r. Small r is equal to that. So in place of the whole of this, I can put the small r, so that this one will be equal to small r times pi capital R. And you are aware that L here is equal to R. So in place of R, I can put there R times pi times L. And that will give you pi R L. And this becomes the total surface area of a cone. That you should know. So in that case, S is equal to, what is the pi? 22 over 7 times the radius 7.99 times 17. So S will be equal to 2 times 7.99 times 17, all divided by 7.
Four two six
426.894. 894. So it will equal to 427 centimeters squared, because it is area. Because the radius here should be centimeters, and the capital also should be centimeters. So centimeters and centimeters will give you centimeters squared. Thank you very much for watching my video. May God bless you. Always follow me on YouTube.